Okay, take a close look at any big construction site. You're going to see two main heroes holding everything up, the classic I-beam and the steel tube. They are literally the backbone of our modern world, but they've got a fascinating secret when it comes to strength.
And that secret is kind of weird. I mean, think about it. How on earth can you make something stronger by taking material away from it? It seems totally backward, right? Well, the answer is just some seriously brilliant engineering. It all comes down to a physics principle called the moment of inertia. Now that sounds complicated, but the core idea is simple. It's basically a fancy way of measuring how well a shape resists being bent. And the key thing to know is that it's not about how much steel you have, it's all about where you put that steel.
Let me walk you through it. So imagine you start with just a solid, chunky block of steel. When you bend it, almost all the hard work is done by the top and the bottom. The material right in the middle, it's barely doing anything. It's just dead weight. So engineers realized, why not just scoop out all that lazy, useless material and push it to the outer edges? And boom, you've just invented the super efficient I-beam.
This shape, also known as a W shape, became the absolute workhorse of the entire construction industry. It's just perfect for handling the bending forces in things like floors and roofs. But here's the twist. That exact same design that makes it so strong also creates a huge, fatal flaw.
You see, the I-beam is fantastic at bending, but it is terrible at resisting any kind of twisting force, what engineers call torsion. That open shape just wants to warp and buckle. For that kind of job, you need a specialist. Enter the hollow structural section, or HSS. It's basically a steel tube, and its closed-off shape makes it an absolute champion against twisting and getting squished.
Because the HSS is just so good at handling those compression and twisting forces, it's the perfect choice for things like columns and bracing. That closed, continuous loop of steel gives it this incredible stability that an open I-beam just can't even dream of matching. And here's the kicker, the real payoff. When engineers use HSS in the right spots, they get the same or even better structural performance while using way less steel. We're talking about reducing the total weight of a structure by up to 15%. That's huge.
So that leads to a pretty obvious question, right? If HSS is so incredibly efficient, why isn't it used everywhere? Why does the good old I-beam still absolutely dominate the market, making up more than 80% of all structural steel used in the US?
Well, the answer isn't about the strength of the steel itself. It all comes down to the hidden cost of fabrication. It turns out that achieving that perfect structural efficiency, well, it comes at a price.
Think about it. Connecting two I-beams is pretty simple. You can just bolt them together quick and easy. But connecting something to a sealed-off tube, all that is way more complicated. It requires specialized, precise cuts and a lot of intensive welding. All that extra labor means a single HSS connection can cost up to 3 times more than a simple I-beam connection.
So, you see, it's not about which shape is strongest. It's always about picking the right tool for the job. The I-beam is the undisputed king for general construction, where speed and keeping labor costs down is everything. But the HSS is the champion for columns, for trusses, or for any design that has to fight twisting forces or needs that slick, modern architectural look. So next time you look at a skyscraper, you'll know its incredible strength isn't just about how much steel is in it, but about the geometry of that steel. So I have a question for you. Knowing what you know now, what shape do you think is best for a suspension bridge tower, which has to handle both massive compression from the weight and constant twisting from the wind? Let me know what you think.